Good afternoon. Good afternoon. So today I got late. It happened because laptop went on update. Sorry. So we shall start the things. I told that we shall do some project here. So now we shall learn how do we work in industry when we do a new project. It's not like that we know everything, and it is not like in industry we find the same PLC which we have already used. No, most of time, every time, we get some new brand which we have not practiced. But it's not like that we are not able to work on new brand. When we get a new project and we get new brand PLC, we gather information about that new brand PLC and we make project. Once you make a program in any software, the same program we can make for any brand of PLC because logic will be the same. NONC will be the same. Only the thing we'll start is addresses and syntax. In new brand, in any other brand, address and syntax will get changed. Like in Codesys, you have used percentage IX 0.0, QX 0.0, MX 0.0. In other brand, the address will get changed. Like for Mitsubishi, it is X input, Y output. For Allen Bradley, it is I colon 0/0. So like that, address will get changed. So when we go to meet client, we ask them which PLC you are going to use. And we ask how many inputs, outputs we have to use. What are the addresses you have connected your inputs, outputs to PLC. After gathering all these informations, it's not like we go to industry and we make program there. We make program at our home, in our office. So the same thing we will do here all together. So change your mindset. Your training is over, you consider. Now onward, we shall work on project. You see, what I want to say, today we shall do one project on PLC. Tomorrow, we shall make some modification and we shall add HMI feature to the existing project. What we shall do today, tomorrow we shall add HMI in that. Tomorrow afternoon, we shall add SCADA in that. Day after tomorrow, we shall do project on AC drive, one separate project. We'll do one project on analog ADC, DAC. We'll do one project on IoT also, one simple program, simple project we shall do on IoT also. So now onward, it's not your training program you consider, it's like we all together are doing some project. We have learned something, and what we don't know, we shall all together, we shall have discussion and we'll gather the informations and we'll make projects. So in our project, what are the things we are going to use? Let me show you here. I think these things should be with you in your notebook because once you mention that you have attended training program on industrial automation, in your resume, if it is there, they will ask you question related to the training program. They can ask you which PLC was that there in the training. What was the name of that model, PLC model? How many inputs, how many outputs did you use? What was the name of HMI, SCADA? Everything they will ask you. So you must have all the things in your notebook. So we are going to use here PLC Mitsubishi. Mitsubishi. Mitsubishi, I shall give you more information about this. Hardware. The hardware we are going to use is FX2N 64MT. FX2N64MT. This is the model name, PLC hardware model name. Because we have different model, we have different hardware. So this is FX2N64MT PLC we shall use in our project. Inputs, outputs, I shall tell you further. First, let us gather information, collect information about Mitsubishi. We will have to, and what are the things we need to collect here? We need to collect what is input address, what is output address, how do we take timer, how do we take flag. So we will have to collect all these informations if we have to make project on Mitsubishi. If you have to do project on Allen Bradley, then you go to internet. Like if you have to get information about this, you search FX2 and 60 in Google, and it will give you some PDF user manual. In user manual, everything will be given. So like that, you have to search your PLC name in Google, and there you can find out user manual PDF. There, all information will be given. Here, I shall give you the informations, few information. See, Mitsubishi is a Japanese brand and is leading brand in automation. It is also called not Mitsubishi but Mitsubishi PLC. Mitsubishi PLC is called MELSEC, MELSEC, MELSEC. Because Mitsubishi has many products. It has car, it has all electrical equipments, it has all automation equipments, it has AC, air conditioner and other things, many things. Among all products, PLC is called MELSEC, so it would be written on Mitsubishi PLC. MELSEC will be written on the hardware. So when someone asks you about MELSEC, you consider it is Mitsubishi PLC. Okay, fine. Now, Mitsubishi PLC, we have micro and modular both. In modular, we have a CPU. It is very old. A CPU, old PLC, rack type. Q and A CPU. Then we have Q CPU also. In Q CPU also we have A mode and Q mode. In Q CPU we have A mode and Q mode. Q mode is latest actually. Q CPU Q mode is latest. In Q CPU Q mode again you have many hardwares. So in each CPU you have many hardwares. Okay, these are modular. And we have FX CPU. FX CPU. FX CPU is micro PLC. Micro you understand, single unit PLC. Modular you understand, it will be big PLC and it will have separate module. FX CPU, again in FX CPU you have many hardwares like FX1S, FX is also there, FX2N, old one is 1N also. So some name I shall write down, FX2N, FX3U, new one, and FX5U, this is also new one. These are hardwares, micro hardwares, micro PLC. So we are going to work on micro PLC here in our project. FX2N we shall use. Although we have other hardwares also. Now software we have FX software now we don't use because GX has all features. So GX developer, GX developer. Sorry, not able to write it properly. GX developer or GX, you can use any. GX Works is latest one, but you can make program in the same way in both softwares. I shall use GX developer, but these two CPU you will find in GX Works, not in GX developer. Okay, GX developer software we shall use. Next. Next thing is you can keep the screenshot. Take this screenshot. I shall delete this. Then I shall tell you about input output. Today I shall make you perfect in Mitsubishi programming. Then you can make experiments by seeing the user manual and can explore more. So I shall remove this. Now input output addresses. Input, you see. Input we have X. So first input would be X0 or 00 also, no problem. It is 0. Then X1 and it will go up to X7. This is octal number system. Here we have octal number system. Octal has 0 to 7 means 8 bits. 0 to 7. Now if you want more address, you have X10, not X8, but X10 to X17, octal number system. Then X20 to X27, like that. See, this octal number system we have in micro. In modular we have hexadecimal number system. Hexadecimal number system will have 0 to 9 and then A to F. A B C D E F. A B C D E F. Yes, isn't it? 16. Yeah. Yeah, correct. It would be X0 if it is modular PLC, means big PLC. It would be X0 to X9 first. It will come to X9 and then XA to XF. And if you want another slot, if you will go, it would be X10 to X1F, like that. But we are going to use here micro PLC. It will have octal number system. Fine. Now you see output. Output is Y in Mitsubishi. So Y0 to Y7 and then Y10 to 17, like that it will go. Done. Flag. Flag we have M, the same. And decimal number system. It means M0, 1, 2, 3, 4, 5, 6. It will continue. There is no octal or hexadecimal. It is decimal. It will continue. So input, output, flag. One more thing we need to know is timer. Timer. Please concentrate. It is different here. And you need to answer me. People, please answer me. Few things I shall ask you. You don't just listen, just reply also so that you don't sleep. So answer me, in timer, on delay timer, how many parameters do we have? Tell me, everyone. On delay timer, how many parameters do we have in all delay timer? How many parameters do we have in on delay timer?
4.
4 parameters. What are the parameters? See, yesterday only you did it. Tell me,
Enable,
how many, what are the parameters, 4 parameters?
enable,
Enable, then
accu- accumulator,
accumulator, then
PT and done, DN.
DN,
So it has four parameters. See, let the timer be in any software. On-delay timer will have four parameters in all softwares: enable bit, preset value, accumulator, and done bit. So in Mitsubishi also we will have those four parameters. In Mitsubishi, it will not come in a box, ready-made block. It will come in coil. So you will have to take coil like you take for output. Very good. You answered correctly. Nice. So you have to take a coil. The same coil what you take for output. In coil, you have to type your timer address. Timer address is T. So first timer will be T0. Second timer, if you want, it would be T1, T2, T3, like that. 256 timers we can use. So T0 to T255. Now, how many seconds I want? I want 5 seconds, suppose. So T0 space K 50. K denotes decimal. 50 is the preset value. In Mitsubishi, preset value is multiple of 10. You cannot change that because its time base is 100 millisecond. You don't go in that. It will take time. If you want to understand, it will take time to explain. For now, you consider your preset value is multiple of 10. So for 5 seconds, you need to write 50. For 10 seconds, you need to write 100. K 100 multiply by 10. Okay? So now you see, this is your timer. This is your timer. After this timer, you have not to take any coil. No, this is not applicable now, because coil is the last element of your ladder. So your ladder will stop here itself. So timer, we have to take in coil. T is the timer. First timer is T0 space reset value. Now four parameters. Let us find out where are the four parameters. This is your enable, correct? This is enable. This is your preset value, correct? Now two more things we need: accumulator and done bit. Remember, accumulator and done bit both will be its address itself. So timer address in Mitsubishi will be its accumulator and done bit as well. It means when this timer will start running, enable is high, timer will start running, the running value 1, 2, 3, 4, 5, 6, you can monitor here itself on T0. So T0 is accumulator, and after 5 seconds, if you have to use its done bit in NONC, then no need to take one flag, but you can use its address directly. So what is the address in this timer? It is T0. So T0 NONC you can use further. No need to take any flag, and you cannot take flag here. So it is clear. If you have timer T1, then T1 will be the done bit. If it is T2 timer, then T2 will be the done bit. Yesterday you made a program, last program, 3 timers. Done bit was M1, M2, M3. If you make the same program in Mitsubishi, then your done bit will be T0, T1, T2. No need to take flag here. Is it clear? We shall make one example and it will be very much clear. Don't worry. It will be clear when we shall make program. For now, do you have any doubt here? Ask me.
Hello, sir.
Hmm.
Sir, when you hold your mic, no, there's a lot of noise coming in.
Is it so?
Yes, sir.
Still coming?
Like now it came on the right hand. It doesn't.
Okay. Now it is okay, right?
No, sir. No.
No. Now okay?
Yes, now it is okay.
Okay, fine. So I have to keep it in right hand. Then how will I run the mouse? Use the mouse. Okay, let me put that on color. Is it okay?
Yes, sir. It's fine. It's fine. I guess.
Okay. then my hand needs to be free. Okay, so you see, I did not understand about that. What is that? About K50. You see, don't be confused. Don't be confused. K50 here, you see, K50. This K50. This is preset value. In codices, you had written no T hash 5S. In Mitsubishi, for 5 seconds, you will have to write 50. Whatever you want. Like I want 10 seconds. What shall I write? K100. I want 3 seconds. Then I shall write K30. If I want 4 seconds, then I will have to type K40, like that. So multiply your preset with 10. That is compulsory here. Why is it so? It is because of time base that I won't explain now. Lastly, if you will ask, after session, I shall explain, but not now. So for now, you remember you have to multiply your preset with 10 in Mitsubishi. Okay, I shall remove this. You can take a screenshot, I shall remove. And one example I shall show you here. On screen, it would be very much clear. I shall remove it. Control A and delete. What is the range of flag M02? I told you, no. In Mitsubishi, I have seen 500, 600 also, there is no issue, but type of flag will change. Like after 500, it will become retentive flag, but below that, it would be normal flag. So range is large. We have large range of flags we can use. No problem. Next, you see. One program we all will make together. Although I could have given you to make this program yourself, but it will take time. Already I started late. So all together we shall make one program on screen. Look at the screen, please. We take one example of codices like I0. We latch this with flag M0. Look at the screen, please. And you will understand after this how we make program in Mitsubishi. And one person Sahib, uh, Delta. For Delta also we make program in the same way, same address. Now M0, you can say Delta is copy of Mitsubishi. Y0. Now from M0 we shall run one timer. Oh, sorry, I have to take here Q0 because this I am writing for codices or general say. Then we will make for Mitsubishi. Q0. From Q M0 we shall take a timer for 5 seconds. After 5 seconds we take M1. From M1 we break Q0, and then we take one another output, that is Q1, and from M1 we take one more timer. Yesterday we made this. We run this for 7 seconds, suppose. M2 will come. Now M2 will break, and everything will be off. We put one manual switch also for stop emergency of I1. Everyone, if you want, you can try to make the same logic for Mitsubishi on your notebook. I am also making on screen. So if you want to check whether you are able to make or not, you can try on your notebook and can verify on screen. So people who want to learn this, look at the screen. If you don't want to write in your notebook, you can directly look at the screen. Now I shall write program for Mitsubishi, the same program. So first we see first ladder, I0 M0 latch. You need to answer me. What is the input address in Mitsubishi? What should I write here?
X00.
X0 or X0. Very good, very good. What is the flag address in Mitsubishi?
M0.
M0, very good. So latch will also have the same address, M0. Now you come to second letter. You ignore these NC we shall put further. Second ladder you come. It is M0Q0. So what it should be M0 and
Y0.
what is the address here? Very good. It will be Y0. Very nice. You people are texting correct. Right, right. Very good. Be involved. Nice. I like this response. Nice. Next, you go for this ladder. One, two, three, third ladder. Now here you need to concentrate. Everyone, concentrate because here you have timer. So first you have M0 and a 5 seconds timer. M0 and a 5 seconds timer. See this. Look at the screen. So M0 and 5 seconds timer. Timer we take in coil. You see, this is the first timer. So I take T0, not TO, T0 space for 5
K50.
seconds. What should I write? Yes, yes,
K50.
very nice, very nice. K50. Yeah, correct, correct. Got this, everyone? Did you get? We made program up to this, not this one. We did not make for M1. We made up to M0 and 5 seconds. Correct.
So is it
Next.
T0 space K50? How is it written?
Yeah, space, space, space. Now you see, very good. You people are doing good. You understand. Now you see this thing. You see M1. M1 has to break first ladder. M1 has to break first ladder. Concentrate. M1 has to break first ladder. What is this M1? M1 is the done bit of first timer, isn't it? M1 is the done bit of 5 seconds timer. What is the done bit address in Mitsubishi? Here, what would be the address, done bit address?
T0, sir.
T0.
T0, because we are not going to take anything after this. Don't take any flag after this because it is already a coil. You can't take any coil after it. So T0 is the done bit. So instead of M1, here it will come T0. Isn't it clear? It's very much clear. Now, next you see M1 and Q1. So what it would be? What it would be? What should I take
M1 and
for this
Y1.
ladder? M1,
Y1.
M1 and
T0
someone
Y1.
someone else
T0
tell me.
Y1.
Y1.
T0 Y1.
T0 T0 Y1. Very good, very good. T0 and Y1 you see. It would be T0 Y1, not M1 because M1 is in Codesis, but in Mitsubishi T0 is the bit. T0 Y1. Great. Next I give you. What should I give?
T0 T1
T,
K70.
T0
T1
T1 K70.
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 and
T1 K70.
T1 space K70. Very
K70.
good,
Yes.
very good. You understood. So you people have texted correctly, but you see, you have to write T1 K50. T0 already you have used. Correct. Now last one you see M has to break latch. M2 will break latch. So what we have to do here? What should be the address to break
T1.
latch?
T1.
T1.
T1. Yes, yes. So T1 will break latch. And what would be the another NC?
X1.
Another X1. Correct, correct. So it is easy. It is easy. And you know, in the same way, you can make program for Allen Bradley, you can make program for Siemens, you can make program for Omron, for any brand. So you have to just collect the addresses and syntax, and you can write any logic for any brand as we have done on screen. If you have any question, please ask me. Then we shall go towards project. If you have any doubt in this, you can ask me. I shall clarify because after this you have to make program. I shall not make program. You have to make program for project. Any question? No question. Okay. Then I shall proceed. Very good. I think you all understood. Now I come to the project. So see, in the same way we work in industry also. It's not like we know about all the brands. It's not like we have worked on all brands of PLC. So when we get a project in industry, we don't say them that I don't know about this brand. If I will say I don't have worked, I have not worked on this brand, they won't give me project. So we don't say that we don't know. We just collect the information and we search its user manual. In a user manual, everything is given. So when you go to industry or if you are in research site, you know that you have to work by reading user manual. User manual every time will help you. Okay, fine. Now I shall remove this and we'll discuss about project. See, first let me show you my connection. I shall show you through webcam also, but I have one video already that let me show you here. Okay, what video is getting opened? In that video, I will show you first what are the things I have connected here, then real-time things also I'll show you. Look at the screen. I hope it is visible to all. Yeah. So you see, I have connected here these three indicators. I have connected here three indicators: red lamp, yellow lamp, green lamp. Next, you see. See, these are the sensors. Although this is my old video, so there I had connected three sensors. In my project today, I have connected two sensors, and those two sensors are photo sensor, the same sensor I have connected today, and one this one, proximity sensor, metal detector. So two sensors I have connected today. The same sensor I used today also. Now you see, these are the, just a minute, let me go back. So these are the push buttons I have connected today also. Green push button, red push button. But let me tell you, button is green, this is anotype, this is red button, but its contact is anotype. Its contact is anotype one. It is anotype only, red also. Next. This is SMPS, the same SMPS I have used today also. In this SMPS, you can see these two are power terminal, line neutral I have given, and these two are positive, negative. You can see it is written also here, but it won't be visible. Positive, negative. Next. 24-volt DC SMPS. This is your PLC you have to use today. This is Mitsubishi FX64MT. 64MT. See, 64 means what? 64 means on this main unit, I have 32 inputs, 32 output terminals. And MT, T means transistor type. If it is MR, then it would be relay type. Okay, so this is your PLC. On this PLC, or actually on any PLC, you will have indicators like this. This is important to see. These indicators are for input. These indicators are for output. Why do we have this? Suppose I press push button, start push button. Then X0 indicator should be on here. If it is on here, means connection is correct. And when you press and this indicator is not on, it means PLC is not getting signal from the input. Then if any output inside your program will get on, respective output indicator will be on your PLC. Then you can understand, okay, my output is on and connected output should be on. Okay, fine. So these indicators you will have. And these indicators are for run, for error, for stop, other things. And this part you see here, this part is the cover. If I remove that, we have here extension port. Through this we extend it. Last day we shall connect ADC DAC. Through that I will show you. Done. Next you see, these are the input terminals, and it won't be very much clear, but it has been written here x0, x1, x2, x3, and here it is written line, neutral, earth. So these are the terminals. So if I have to connect to x0, then I will see here x0, it goes here. So it is the terminal for x0. X1 you see, x1 goes here. So this is x1 terminal, like that. Next you see, this is your communication port. It is round port RS422. You can have other port also on other PLC brand. And this is the RAID cable, the communication cable for Mitsubishi only. You cannot use another cable here. You have to use Mitsubishi communication cable. Now these are output terminals. And here you can see this is Y4, Y5, this is Y0, Y1, Y2, Y3. Like that, we have 32 in output terminals here. Okay, done. You see, in our project, we have one AC drive. This is our AC drive that you call frequency drive. What do you call it? VFD.
VFD, sir.
Variable.
VFD.
Correct. Variable frequency drive. So this is the variable frequency drive. This is also from Mitsubishi. It is Frict Roll FR 520 series. So this is Mitsubishi brand AC drive. This I have used in our project to change the direction of motor forward reverse. It's multi-speed operation we will use day after tomorrow. So this is the VFD. It will show the frequency on that screen. And this is motor. And do you know, this motor is 3-phase, but 230 volt. 3-phase, 230 volt. I shall explain this day after tomorrow. For now, AC drive we use. To AC drive we connect only 3-phase motors. Always we connect 3-phase motors to AC drive. So as this AC drive needs 230 volt to get powered on, so it returns 230 only, but it splits it in 3 phases. So this motor is a special motor for 3-phase but 230 volt AC. Okay. Day after tomorrow we will have more discussion about AC drive. Now you see, leave it. This I will show you when we will make program. We will make program. When we will download, then I will show you this. That was the execution. So you have seen here the same connection we have. I shall try to show you. First I will stop sharing and will come on full screen. I shall come on full screen. Then you tell me whether it is visible or not. I am not sure. I'm not sure whether it is clearly visible or not. Obviously not very much clear, but I can show you. This is PLC, and here you see this is RAID push button but anotype. See, I'll show you how anotype. Behind this push button, listen, behind this push button I have connected 2 contacts, whereas in industry you will have only 1 contact, but I have connected 2 so that I can keep it stand. So you can see this wire I have connected to green contact. Green contact is NO type. I have not connected to red one. If I connect to red one, then I will have to change my program. So green means this red push button is also NO type. So both are NO type. Okay. Now you can see I have sensors here. This is photo sensor. This is photo sensor. Now this one. This is proximity metal detector. Then I'll show you our indicators. Green lamp you see. This is green indicator. This is yellow indicator. And this is live. It is not in video. It's red indicator. And here is our SMPS. This is our VFD and motor you can see there. Can you see there? Motor. That is the motor. And when we will run, I shall show you. Okay. Again, I shall come on share screen and will give you assignment. You people have to, I am the client now and you are the programmer. You all are the programmer. So I shall tell you what are the things I am going to use in my machine. Machine is already wired. In industry, it is often like that. When they make project, they wire the thing. Everything will be ready. You are a programmer. You go make program, download to PLC and run it. So you are a programmer. I am client. I shall tell you what I have to do. You make program accordingly. Okay. So note down what are the things we have in our project, and you can keep all these projects with you, and you can explain this in interview also. In resume you can mention. So here you see you have a project where you have Mitsubishi, you have noted down, right? You have already noted down FX2N64MT. Okay. Then inputs you see to X0 terminal. I have connected starter. To X1, what 24 volt DC? You are asking something? To X1, I have connected stop push button. See, this is required for you because where have I connected in program? You have to use addresses only. So X1, X2, I have used for metal detector. So what should I write? Metal, I write a metal sensor. Metal sensor. X3 is photo sensor. Photo sensor. Then these are the inputs only. And now output you see. Outputs Y0 you have connected red. Actually, I have connected red. Y1 I have connected yellow. Y2 I have connected green. Our motor will run in forward direction and reverse direction, in reverse direction as well. So forward direction I have connected to Y4. See, it depends on me. I have not connected to Y3. I have connected to Y4. It is my choice. You can't say why did you use Y4? Why not Y3? It's my choice. So it is for forward direction operation. Now Y10 I have used for reverse direction rotation. So these are, note down in your notebook. These all things should be there in your notebook. So these are the outputs and inputs. Note down please. And I should tell you the name of AC drive also. It should be with you. Let me take a photo first because it's very small, written very small. This side. Just a minute. AC drive name also you should know, because they can ask you which AC drive did you use. AC drive is FR, Mitsubishi FR. FR is Frick roll, and FR series is 520 SE and zero point 0.4 kilowatt. Okay, and do you know this AC drive can control frequency 0.5 hertz to 120 hertz. Okay, let it be. That we will discuss day after tomorrow. So this is the information of your machine. This is the detail of machine what we have in our machine. So I shall remove this. I hope you have taken screenshot and note it down in your notebook. Now I shall remove it. Should I remove this? Let it be. Now I shall tell you the sequence. Listen carefully, everyone. This is the important part, sequence. According to that, you have to write program in Mitsubishi uh, format. When we press X0, listen carefully. When we press X0 start push button, red lamp should get on for 5 seconds. As we press start push button X0, red lamp should get on for 5 seconds. After 5 seconds, red will be off and yellow should get on for 3 seconds. Yellow should get on for 3 seconds. Got it? Once more. Press start push button. Red should get on for 5 seconds. After 5 seconds, red off, yellow should get on for 3 seconds. After 3 seconds, yellow off and forward should get on. See here, directly come to forward direction. Forward direction should get on for 6 seconds. Forward direction should get on for 3 seconds. 6 seconds. After 6 seconds, forward off, reverse will get on.
Can you just repeat after yellow? After 3 seconds yellow?
Okay, I shall repeat once more, no problem. Once more, you see. When you press start push button, red will get on for 5 seconds. After 5 seconds, red off, yellow on for 3 seconds. After 3 seconds, yellow off. After 3 seconds, yellow off. Forward direction should get on for 6 seconds. Forward on for 6 seconds. Forward on for 6 seconds. After 6 seconds, reverse should get on. Forward off. After 6 seconds, forward off. After 6 seconds, forward off. Reverse should get on for 7 seconds. Reverse should get on for 7 seconds. First, you people make program up to this, then I shall tell you the role of metal sensor and green. First, you make up to this. Everyone, I think maximum 5 minutes you will take. It won't take 5 minutes even. Yesterday you made program, three timer program. In the same way you have to make this program also. Follow the steps, make program and send it in group. So you are going to make real-time project. This is a real-time project. Please make program for this first and send in group.
Hi, sir. Sudip here. All these input switches are latching, right? We need to latch everything.
Yeah, actually, we have only one push button. Yet I have told you have to
Okay.
latch because it is a push button. Yeah, X0 you have to latch. So they,
Okay. Thank you.
we have to make program in the same way how we followed yesterday. Correct? Yesterday we made program for three outputs, three timers. We have the same sequence here also. Once more, I shall repeat: X0 on, red on 5 seconds. After 5 seconds, red off. Yellow on for 3 seconds. After 3 seconds, yellow off. Forward on for 6 seconds. After 6 seconds, forward off. Reverse on for 7 seconds. Yesterday we had 3 outputs. Today we have 4 outputs. That is it. Nothing else. And you have to make this in Mitsubishi format. If you have confusion, then you make in codices format. Very good. X0, M0, M0, 0, T0, T0, T1, T1. Correct, correct. Y4, Y10. Correct. Very good. NNM. Correct. JOS. It is X0, M0, T0, T0, T1, T1. Very good, very good. Correct. Satvik, M0, M0, T0, T0. Satvik and Sukumar, you have to break latch probe T3. Other things correct. Akshay Patil, you have also to break latch probe T3. Other things correct. Very good. Everyone is correct. Very nice. Ways correct. Satyam, you have to break. You have broken Y10. No need to break Y10 from T3. Just break latch. If you break latch, everything will be off itself. Here, T3. Akam, you have to break latch from T3. Other things correct. Done, done. Very good. Ankit, correct. Nitish, correct. Very good. So all have made it correct. So better we all uh, make it once on screen because, or leave it. First you do some modification, then I shall finally make on screen. People who have made this and who have been making this, one modification is required here. Jatin, correct. T2, yes, correct. Y0. Vishal, correct. But for this project, you keep X1 and C because it is anno type push button. Correct. You people listen first. Listen first. Now listen, everyone. Listen, everyone. Everyone has made it correct. Modification. I told no. Green and proximity sensor we have to add here. Correct. So you all are making correct. Devanka, correct. Muhammad Abu, correct. Correct. Please stop now and if you will keep sending. Sudeep 000 T0, correct, correct. T3. Sudeep, latch break NC address will be T3. Correct. Yours is correct. Now listen first, everyone. Now we have to fit our sensor in our project. Sensor is connected to X2. This is metal detector. Our purpose of the sensor is, suppose there is some fixture or there is some job which should not move from its direction, its position. So we have put one metal detector. If the fixture or the job moves away from the sensor range, sensor is off, X2 is off. If X2 is off, your machine should stop itself. Another thing, when you press a start push button and X2 is not on, machine will not start. Try to understand the condition. When you press a start button, X2 must be on. If X2 is off, then it won't start. If X2 is off, it won't start. In between process, if X2 gets off, then also machine will stop. Another thing, whenever motor runs either in forward or reverse direction, whenever motor runs either in forward or reverse direction, green should be on with that. Green should be on with that. Did you understand the condition for sensor and green? Your X2 sensor should be always on. This is the condition. If it is not on, machine will not start. If it is off in between process, machine will stop. Green will be on with red and forward and reverse. Green will be on with forward and reverse. Make this modification. Correct. Correct. Break latch from T3. Then Ravi Teja T0, T1, T2. You have to take one more timer, Ravi. T3 will come after Y10, T3 will come T2 and T3K70 will come and T3 will break latch. Ravi Teja, make modification. Other guys, you understood that X2 should always be on to run the machine and green will be on with forward and reverse. That you have to do. Very good, Jose. That's correct. That is correct, Jose. You have made it correct. Let me also make this program. So X0 and X1 is emergency off. X1 will break latch. Don't worry about that. X1 will break latch like this. And you see X2 you have to put like this one. M0, X2. And we need a latch. From M0 red lamp Y0 will be on. From M0 timer will run. for 5 seconds, K50. So T0 will break this, and T0 will run another output Y1, that is in yellow color. From T0, the timer T1 will run for 3 seconds. T1 will break Y1. T1 will run Y10, Y4 actually. So its mic is on. T1
Sorry, sir.
and no problem. That is T2, K60. So T2 will break this. Correct. Look at the screen. One modification I shall make here. Here we have now T2. From T2, Y10 will be on, and now T2 will run a timer T3 for 7 seconds. Done. Now you see this T3. Okay, leave it. T3 part I shall do once again. Now we have to add green. See, you have two ways you can use it. First thing is, as your forward direction is on, at the same time,
Sir, your voice is very low.
what to do? Okay. Is it okay?
Yes, sir.
So when forward direction is on, at the same time let us make green on, because once T1 comes, see this, once T1 gets on, it is continue on, correct? T1 is continue on because timer is set. So once T1 comes, let us make Y2 on, that is your green color lamp. Got this? So this you can use T1 and Y2. Another option is you can take, means this is optional, either you take this ladder or you take this ladder, not both. Whenever Y4 or Y10, some students have done like this, that is correct actually. Y10, either this or that is on, Y2 should be on. Or you can use this ladder also. Either you use this ladder or you use this ladder. It will work. Sudeep, you have taken Y5, Y4 XOR, but we have Y4 and Y10 XOR if you want. Y4, Y10.
It is Y4 and Y10.
Yes.
Yeah, it is
So,
Y10, and I did it for the sake of interlocking, because a motor cannot be in both forward direction as well as reverse direction, which will lead to short circuit. So even at that time, we might lose the motor as well. So to be on a safer side, we need to take the interlocking to secure our motor.
correct. Your point is correct, but once you make connection from AC drive to PLC, then AC drive has its own interlock that it won't make both the outputs on at the same time, but your point is correct. XOR you have made, that is very good. Okay, fine. Next, you see, now we all will uh, learn Mitsubishi software, that is GX developer I shall use. You can use GX Works also. Both softwares will be similar. So I shall remove this. If you want its screenshot, you can keep. I shall go for software now. So I shall search here GX. I shall search GX. I have already installed. It is not with you and cannot be shared with you. You need to look at the screen only. GX developer.
Do we get this software whenever we are purchasing a Mitsubishi PLC, or we should get it additionally?
See, if you go for branded PLCs like Mitsubishi, Allen Bradley, Siemens, they will sell everything. They will sell PLC, they will sell software, they will sell communication cable also. Do you know this red cable cost is 17,000. If you go for Siemens communication cable will come in 37,000, 38,000. So they have to sell everything. So it's not free; it's licensed. But cracks are available on internet. I must say. Look at the screen, please, everyone. We are going to learn here Mitsubishi GX developer software. How do we? And this is a real time. It's not demo. I shall show you the connection and all everything. First, as this software is open, or if you work with Allen Bradley or Siemens, whenever you open a new software, you have to take a new file. So we take new file. As we take new file, it will ask you which PLC you are going to use because it has many PLC hardwares. So you see, I have told you Q CPU, Q mode, Q CPU, A mode, QNA CPU, A CPU, motion CPU. See, this motion CPU is for robots, robotic arms. Then FX CPU, CNC CPU also they have if you have CNC machines. See here, FX CPU we have to select because we have FX PLC selected. In FX also you see FX0S, FX0N, FX1, FX1S, 1NC, FXU. So there are many. We have to take FX2N. We have to take FX2N. I have taken. Now you see ladder is already selected. I click OK. It has come. It has come. Here, you don't need to take new ladder, it will automatically come. So you start making your program from here, this ladder. So you can see here NO, parallel NO, NC, parallel NC, coil, box, then you can say horizontal. Yes, horizontal line if you want, vertical line you want, horizontal delete, vertical delete. This is positive pulse, negative pulse, parallel positive pulse, parallel negative pulse. So there are many things they have given here. So we have to click this and we have to take NO. You can use your keyboard also, F. You can see F5, the shortcut key. So I shall use mouse only so that you all can see this. I shall make this program. Look at the screen. As you, once more, as you take this NO, immediately it will ask you address. So address is X0, enter, has come. Then I want NC. So I shall take here x1. I want an O. I shall take here x2. x3 I have not used. That we will see. We will modify in next project. So x2. Now you want coil, you see. Coil. You don't need to go here, or else you will have to add all these things. So better you be here and take coil and give it M0. Now you see you want parallel. In Mitsubishi, don't click here. If you click here and you take parallel, you see M0. Enter. It is saying the edit, it says the edit position is incorrect. Means you have selected wrong position. You come down to next ladder. Automatically it came. So you come to next ladder, click here, and then you take parallel. M0. Now you come to next ladder and take NO. Here you have to take M0 and you have to take a coil Y0. When you come to NO and it is M0 and coil. You see timer I'm taking, timer. The same coil. Coil T0 space K50. You see your timer has come here. Timer has come. Now you want T0NC here. Now let me use shortcut, it would be fast. T0 you have to give. I come to this and I'm using F5. As I click F5, NO will come. And here I have to take T0 and NC I want, that is T1. While I want F7, that is Y1. Next, and I take here T0. From T0 I want a coil F7, that is T1 space K 3030. From T1 you have to start. So T1. From T1 what you have to take? Y. First you have to break it. That is T2. Need a coil Y0, Y1, Y4. Y4. Now from Y4, sorry, T1 paper, that is T2, T2 space K60. Then you have to take T2, and from T2 you have to take Y10. Now from T2 you have to take another timer T3 space K70. Okay. That NC and all I shall do further, but if you want to note down, you note down, write down please, or you can see this in video also further. So let me proceed. As you make program in Mitsubishi or you modify existing program, you can see on screen the color has become gray. It was white, now it is gray. I don't know what color you call it. I call it gray. So it has become gray. It has changed the color. When color is changed, it says compile, means kind of login. You did login in Codesys. The same thing it is asking you after making program, you have to compile it. That is convert here. Look at the screen. Can you see this convert here? In convert, you have option convert. F4 is the shortcut. You click this. Now you see it is white color. Now you save this first. Save it. I save it with project 1 P1. I have given it. name you can give. Same.
Sir, sorry to interrupt. Can you please explain the latching process again?
Yeah, once more I shall do that. See what I told. Let me delete it first. See this line, how will you delete this line? If you have to delete this, can you see this line? Vertical. You come up and then you go for this vertical delete. So you can see if I click X0 and I take parallel and will give M0, enter, it is saying that position is incorrect. It means by clicking X0 you can't take latch below this. So first you come below actually. First you come below and then you take latch. So M0. Again you see I modified and color is changed. So I will have to convert and will do Control S. One thing
Yeah, and what if we have to take parallel for two components?
parallel for these two,
Like if you want to latch for both x0 as well as x1.
then what I shall do here in this software, I shall delete this. First, let me delete this. And let me delete this also first. In that case, I will have to take NO actually. I shall take M0, NO, and two options I have. I have this horizontal line, I shall extend it, will go up, and I have here vertical line. It will be like that. Or after taking this M0, what shall I do? I shall go to this one. You see, it is free draw line. So I shall click this and will draw free line. So we have both options. One by one you come or free line you draw. Okay. Now I want to delete this. So free draw, delete free draw line. I click this, will delete this, and will add like this. So we have various options. Will convert and will save again. Very fast, I shall show you here. Look at the screen, please. Okay, I have not taken this one. I have to take. And another thing, what I want, if you break this by M3, what will happen? After M3, after 7 seconds, everything will get off. But my requirement is no, don't switch off everything. After this is the cycle over condition. Here cycle is over, one cycle is over. After one cycle is over, it should repeat the process. Means it should not stop, but process should repeat itself. I don't need to press a start button many times. Once I press a start button, one cycle is over, another cycle will start itself. In that case, do not break latch. In that case, do not break latch. So you see, I have removed. How to repeat? To repeat process, take last signal. This is the last signal, T3. Take last signal, break first timer. Break first timer. Don't break latch. But you break first timer, it will repeat the process. You can note down this thing. In your program, you write down. Remove your M3 break from latch, you remove, and you put that in in first timer ladder. So M3 will break first timer. Okay. So I will
Sir, is it
give
M3 or
M3
T3?
break. Sorry, T3. Yes, I'm sorry. I'm very sorry.
Okay, okay.
It is T3. So I also made mistake. It is T3. I'm sorry. I shall make modification here also. I want T3, and that thing also I have to do that T1 will run. T1 is an O will run by 2, that is green. Convert and and save. I hope it is clear up to this. Till now, it's clear. Tell me if you have any doubt. You tell me, then I shall show you finally how to communicate, how to download. Is it clear up to this? Any doubt you ask me, I shall clear that. No problem. Anything you want here on screen in software? If you want,
Yes, sir.
tell me. Tell me.
Sir, my question is that if I ordered in the courses and should we say PLC is access or not?
Hmm. So I think you want to know that can we use Codesis software for Mitsubishi PLC?
Yes, yes, yes.
No, we cannot. I told different brand, different software. Mitsubishi has GX, you cannot use other software. See, Codesis software is for next gen PLC. That is Pune manufacturer. Its manufacturing unit is in Pune. Next gen PLC. That was actually Mesung, MESSUNG. Now Mesung is purchased by Mitsubishi. So now Mitsubishi is looking after next gen. So Mesang has been bought by Mitsubishi. Okay, done. Now you say, yeah, tell me.
Hello. Sir, why we are adding T3 in timer one ladder? Sir, please explain.
Where I didn't understand.
Sir, to repeat the process, we are adding T3
Yes,
NC switch in
first time.
timer one ladder.
Hmm.
Sir, why we are doing?
So how will it repeat the process you want to know, right?
Yes, sir.
So kindly remind me this question. When we will finish this project, I will tell you. Okay, remind me please.
Okay, sir.
Now I show you people how do we communicate. So first of all, we need its communication cable. We need its communication cable. So now I will stop sharing the things to bring me on full screen. Bring me on full screen. I'll share, but before that, let me show you a few things here. Can you bring me on full screen? Can you see me on full screen, everyone?
Yes, sir.
Okay. So now you see this
Yes, sir.
red cable. Okay, this red cable. This red cable is for Mitsubishi. We cannot use another cable here. So its one end has gone to PLC, you can see there. It's one end here, you see. I have connected to PLC. One end round port I have connected to PLC. And this is this is your another end, next end. So this I need to connect to our computer or laptop. But on our new computer, on our laptop, we do not have 9-pin port. It is 9-pin port. It is 9-pin. So that serial port we don't have on our laptop. So we must have this USB to serial converter, correct? You are familiar with this. USB to serial converter. Nowadays, every engineer needs to have this with you because you won't have serial port on your laptop. So what you do, this serial you connect to this port. Now your PLC cable has gone to USB to serial converter, and this USB will go to your laptop or computer. This USB will go to laptop or computer. Now let me show you. I shall share the screen once. Now on laptop we have On laptop we have many USB ports, 3, 2, 4, there are many. On computer also we have many USB ports. So when you connect this USB to any USB port, to which COM port it has been connected, we need to check, because each port, USB port, will have its own address. That address we need to know. Where can we check that address, USB address? In device manager. I shall go to device manager just to show you. Everything should be very much clear here. So I shall open device manager first. Then I shall connect it. It will be more clear. You can see it will be detected and you can see the component. One more thing. If you have this USB to serial converter with you, you will get its driver file also when you purchase it, either in one small disk or you download from internet and install in your computer. If not installed, it won't be detected. So your USB to serial driver must be installed in your laptop. Now you can see this one, this part. As I connect, you see it will read now. Reading. Here you see port, PORTS, ports. Here, explore this, and here can you read USB to serial communication port COM port number? Can you see that? What is the COM port number?
3.
3.
3. Very good. It's COM port number 3. Now I shall show you, if you change this COM port, its address will change. So I shall remove mouse and will connect, because I have only two USB port. So I have removed mouse. Now I remove this USB cable. See, I have removed, it has gone. It has gone. Now I connect it to another USB port. Now you can see where is port here. It is not installed yet. It is being installed. This port is not configured yet. Now configured. So now you can see it is COM port number 4. It is COM port number 4. It is visible on your screen. So as you change your COM port, you have to check, because this COM port will be required in your software to communicate your laptop with PLC. So I shall now remove from this. We'll put to COM port number 3 itself, and we'll connect mouse. I hope it is clear. When you use USB to serial cable, you should install its driver first. Then in device manager, you should check the COM port number. Ours is COM port number 3. We have checked. It is shown here. I shall remove it. Now I go to GX developer. Here you see. It is visible on your screen. Here, program is ready. Yes. Now you see, first you need to communicate your laptop with PLC. So for communication, you see the steps. For communication, it is online transfer setup. Online transfer setup. It is on your screen. You can see that. As I click, this has been opened, and here already COM port 3 I had selected. But by default, actually, it will show you COM port number 1 like this. It will show you like this. So when you connect your cable, serial cable, to serial port 9 pin, then it will be by default COM port 1. But in case of USB, it will be changed, As it is changed, com port 3 we have. So what shall we do? We shall double click this serial, will select our com port number 3, and this transmission speed baud rate, let it be default. Okay. So only the thing you have to do, once more I shall show you, online, transfer setup, double click this serial and set your com port number as per device manager. Okay. Now, in all PLC softwares, you have option to check whether it is communicating or not. So click this connection test and you see successfully connected with the FX2 and CPU. So it will read your CPU name also. Okay. Okay, you make. Done. One thing let me tell you. Again, you set this, check connection, it is successful. After that, if you don't make this okay, then it won't be communicated. So you have to click this okay. Don't skip this. I had made this mistake, and it took long time to communicate my PLC. So that okay is very powerful. You have to click that. Okay, nice. Now I shall show you how do we download program to PLC. For Mitsubishi, for Allen Bradley, for Siemens, for Delta, for Omron, everywhere you have option to send it, but with a different name. In Mitsubishi, they have given name write to PLC. In some PLC, like Allen Bradley, they have given download. In some PLC, they have given PC to PLC. In some PLC, they have given send to PLC. So let it be any name, we have to send it. In Mitsubishi, you have two options. One is lengthy, it will take some time to send your program, and another is very fast. First one, let me show you. Online transfer setup, sorry, online write to PLC. Can you see this third one? Write to PLC. As I click, this will come. I have to send main program and parameter of the PLC. You can select this from here also, program plus parameter. Parameter is not required all the time, but first time better you download. So program plus parameter I have selected. Then simply I shall click execute and my program will be downloaded, but it will take some time. Why? Because it will send maximum range of this software. But I want to send limited range, like how many steps I have used in my program, that I can check on last ladder. See this. Can you see this here? 35, last ladder 3, 5. So this software has calculated that you have used 35 steps to make this program. So why don't we send only 35, or else it will send maximum steps. I don't know how many steps it has. I will have to check in catalog. So it will send maximum steps. It might be more than 5,000 steps also. So 35 steps only I shall download. It will be very fast. So once more, let me tell you how to download. After communication, you go to the last ladder. This is for Mitsubishi. For other software, you have not to select all these things. Directly you can send it. So go to last ladder, check how many steps, 35. Now you go to online, write to PLC. Select program plus parameter. Then you go to program, look at this, program, program. As I select, it is whole range. I don't want whole range. I shall click this. I want step range. Step range from 0 to 35, right? 35, 35. And I shall click execute. You see, I am clicking it. Look at this screen. Yes. As I click yes, it will send your program to PLC. Now it is sending, you see. And it is done. Your program has been sent. Your program has been sent. You see, I have selected here parameter. If I don't select parameter, you see, write to PLC. Main only I select and program step range 35. Execute, yes, and it is done, you see. So second, I think not 1 second even, it will be done very fast. Close. Now you don't need this software. This software is not required. Now your program is inside PLC. You can remove your cable from laptop, remove all communication cable. You take that, keep that in your bag. Your PLC has one program inside it, and it is connected to field devices, inputs, outputs. Now it will work. So now I shall once show you, I shall stop sharing, bring me on main screen, bring me on full screen, and I shall show you its execution. So it has one program inside it. Though first I would try to show you some problem so that you can learn a bit of troubleshooting also. So it's not like that when you download your program, everything will be okay and it will run in one attempt. Some problem you might face. So let us face some problem, because in training, if you don't face problem, training is not proper. So everything should not be okay. Some problem should come. So I shall create some problem. You know the sequence, right? You know the sequence. And the sequence was, first let me check whether it is visible or not. Green lamp, yellow lamp, and red lamp. Okay, red, yellow, green. Okay, fine. It is visible. Red, yellow, green. Push button, start, and stop. Okay. Motor is not visible. Now motor is also visible. But let me adjust motor. It is visible. Correct. This one is in between. So this is your motor. Done. So you can see. Wait. You can see when motor will run, it will change its direction. Now, you know the sequence. Can anyone tell me what is the sequence to operate this machine? Can anyone tell me the sequence, please? Someone, you tell me what is the sequence?
Yeah, so once the green switch is on, which is the first one, F0 is on, red light should on for 5 seconds.
It should on 5 seconds, okay?
After that, red should off and yellow should on for 3 seconds. And after 3 seconds, yellow should off and motor should run in forward direction for 6 seconds. And after that, motor should run in the reverse direction for 7 seconds. And throughout the duration when motor is on, either in forward or reverse direction, green lamp should be on.
Okay, and after that it should repeat the
Repeat
process,
itself,
right?
yes.
Yes. So when I press start push button, red should get on. So look at the screen. I am going to press start push button. You have to see this red. It should be on. I press it. But you see it is not on. I press this, but it is not on. Let me check what is the issue. So very first what you should do, I'm telling you the practical things, how we check. First you should press this and should check on your PLC indicator. I had shown you know indicator, input indicator. You should check whether your indicator is on or not. Yes, I can see my X0 indicator on PLC is on. It means there is no problem of connection. Push button is working well. Next, I shall tell you the easiest way to troubleshoot. How can you troubleshoot? Now I shall again share screen and will share the software. Through software you can check it easily. So I shall tell you the proper way of troubleshooting, how we do that. Keep patience. This is important because when you go to industry, troubleshooting is important. Now, can you see GX developer?
Yes, sir.
Yes, sir.
So what shall I do actually? First, I shall close this. I shall close this. Suppose I have come to this industry and this industry has problem that their machine is not starting and they are not able to understand what is the problem. So I have come here, I don't know what is the program inside PLC. Okay, I don't know anything. So I shall just open GX developer. So I shall open GX developer. See, this is the step. These are the real steps we follow in industry. Though very first we try to find out in hardware because we know we have habit, we have practice. We reach to problem by hardware only, build devices only. But this is the easiest way, software. And I know many people know what is the problem, but you see how we do. So your GX is open. First you open software, connect your PLC to laptop. Connect your PLC to laptop. Then check COM port number in device manager and you go to this shortcut is for read from PLC or you go to online. In online it is read from PLC. It will ask which CPU. We have FX CPU. Okay. Now it will ask you to check COM port. You see COM port number 1, we have to make it 3. Okay. And connection test. Okay. Now you make it okay. Now it will ask you to read from PLC means receive from PLC, upload from PLC. See, in microcontroller upload means send, but in PLC upload means receive. Now only main let me select, or you can select parameter also. And if I click execute, and actually you should not select this range. You should not select this range because you don't know how many steps we have inside PLC. You have come now only. It is new for you. So you should not select this, but you should do whole range execution. But I know because it will take time, so I shall select range. But you should not select range, honestly. I know it is below 100, so I shall execute. We should not select range, we should receive complete program. This is wrong what I did, selecting this one, but it is fast. Now, as I received, you see, just now I have taken program from PLC. It is not the program I have saved. No, it is not the program I have saved. You can see this. I close it. Now it is asking to save it because it is not saved. Okay, no. So this is your program which has come from PLC just now. Now you see, how do we check? We go to monitor mode. Here you see monitor mode shortcut, or you go to online monitor mode F3. Now your software is online with PLC. Now your software is online with PLC. Everyone look at the screen. Now troubleshooting will start. So you know, if I press X0, this Y0 should get on. And we will see why this Y0 not getting supply. Okay, now you see. First, let me show you. I am going to press X1. See, on your screen, you see, I am going to press X1. In software, you can see the status of X1. Is it okay? X1 is being operated, correct? So this X1 is being operated because I am pressing the hardware switch from machine. So I'm pressing X1 switch, you can see the status. Okay. Now look at the screen. I am going to start the machine. I press start push button. See, X0 is on, correct? No, X0 is on, but Y0 is not on. Can you tell me what is the problem? Can you tell me?
Sir, X2 is NO.
You see here, X0 is blue conducting, X1 is blue conducting, but X2 is open, it is white, it is not conducting. That's why M0 is not on. And M0 not on means Y0 will not get on, correct? So you reached to the problem directly. So X2 is the issue. Now you will ask the operator or electrician, what is this X2? He will check and will tell you, okay, it is a sensor. And then you will reach to that sensor and will check whether it is out of order or its position is moved. Now I am going to fix the position. You see, look at the screen. See, the sensor is on now. The sensor is on now. And if I press start push button, first let me show you on software, then I will show you video also. I press this X0. You see, isn't it on? And timer is running. Then Y1 is on, yellow lamp is on, I can see green is on and forward direction. Okay. Then reverse direction, Y10, you see. And then it will repeat, you see, Y0 will be on after that. You see, again it is on. If I press stop button, you see it will stop. Stopped. Then you can go to write mode. Write mode is log out actually. Write mode, let it be. Now I stop sharing and will show you on main screen. Bring me on main screen, please. That is clear, right? That is clear. Now, sensor is visible. No, sensor is not visible. Let me do one thing. I shall show you sensor also. This is the sensor, okay? This one. And to sense, this photo sensor is also a metal here. So here I have put, you can see here actually red light will be on. See, red light is on, it is on. Now you can see if I press this push button, this red lamp should get on. And let me connect AC drive also. AC drive I have kept off. Let me on this, then only motor will run. Now motor will also run. Everyone, look at the screen. This is the push button, this is the red lamp. So I press it. Here, here. This is yellow lamp. It is on actually. Here. Now motor you can see motor has been running in forward direction. Now you are not able to see it. Reverse direction. Now again you see this red lamp is on. Process repeat. Then yellow lamp is on. And again your motor has been running. If sensor is moved, you see. If sensor is moved from its position, as per our logic, it will be off. So I hope you understand it. So you have understood how to write a program in new brand, how to communicate, and how to send that to PLC. I have told you, I have shown you here. Upload also. Upload means receiving existing program. If you don't have program backup, you can go to PLC, and in run mode also, machine has been running. In running process also, you can receive existing program. Any question? Any question? If you have, you ask me.
Hi, sir. Actually, this question is not related to what we have done today, but I wanted to know what are the drawbacks of PLC? Maybe security concerns.
Uh, Drawback, it's very difficult to find out drawbacks. Uh, so I have not even thought about that because I didn't get this question. But security concern, we have never heard that it got hacked or anything. And virus also, we don't have virus effect in its software or in its memory. We don't have problem of virus attack and all. And I will have to think about its drawback, and might be I shall tell you tomorrow. Let me think what are the drawbacks. Immediately, I cannot say you honestly. Other people,
Uh,
ah, tell me.
and is there any immediate replacement for that? I mean, like in near future, can we see any similar replacement to PLCs and in new technology, or it
Nowadays,
might take some more time?
nowadays, when you go to big industries, for whole industry execution, nowadays they have been using DCS, distributed control system. That DCS is the advanced version of PLC. How I shall tell you. PLC will control the machine, DCS will also control the machine. With PLC, you interface SCADA. So DCS will have inbuilt SCADA system with it. Important thing, in process industries, in oil and gas industries, they use redundant system, redundancy. In redundant system, what happens? Actually, for that, I have not went through PLC scan. PLC scan is important to understand redundancy. But in short, I shall tell you, when you operate any input on or off for both, when you operate any input on or off, or in your program any done bit gets on off, PLC scan starts, or you can say PLC execution starts. And PLC scan or execution takes place in 3 steps. It would be input scan, then logic scan, then output scan. Sometimes 4 types also you will find, 4 steps also you will find, but mainly we have 3 steps to execute PLC or scan PLC scan. We'll have 3 steps. In input scan, all maximum input addresses in our PLC memory will be checked. What is the status? Suppose only one push button I press, but all input status will be checked in input scan. After that update, it will go for logic scan. In logic scan, it will check your program one by one, ladder by ladder. So one ladder left to right, next down, left to right, left to right. It will go to bottom. So as per input scan, logic scan will start and it will update the status of all coils. What is the status of all coils? So it will get one update. Okay, this is on, this is off. After this update, it will go for output scan. In output scan, it will check all output memory and will give update. As per logic scan, it got some update, this output on, this output off. It will update in memory. As memory is updated, output memory is updated, output scan is over, then physical output status will change. Like after that only your motor will get on off, your lamp will get on off, or any output will be on. So if you don't have any of these three steps, input scan, logic scan, output scan, if you don't have any step, your physical output status will not change. This is scan, PLC scan. I won't go in its detail, we don't have enough time for that. Now, redundant system, how does it work? Redundant system, initially I had seen, I was in Iran, and there was one redundant system, especially we had gone for that system only, redundant system. Old PLC, Mitsubishi, old PLC, redundant CPU they had used. So now also, if you have to make two CPUs redundant, you can purchase two identical PLCs. Generally, modular PLC they purchase. Two identical PLC means same CPU, same number of inputs, same number of outputs, interconnected with each other. Both PLCs will be interconnected with each other. Then program will be sent to both. Program logic will be sent to both, and some redundant logic will be written. Like they will generate condition. Okay, if this fails, this should happen. If this fails, this should happen. So they will write program in both PLCs, same program. Now you see what happens. Input output field devices will be connected to both PLCs using some relay. Now two PLCs you have identical. One will be master, another will be slave. Means another you can say standby PLC. But it is hot standby, not cold standby. Hot standby means both will execute. Cold standby means one is kept idle, it is not working. So it is hot standby, redundancy. What will happen? As process will start, scan will start for both PLCs. So logic scan will, input scan will start for both. Logic will be for both, but output scan you will have in master only, slave will not give you output scan. So if slave is not giving you output scan, it means its output terminal will not be excited. So master PLC is giving you input, logic, output scan. So master is controlling all the outputs. If suppose scan is going on, input scan started and master got some problem, no problem. It is going on. It will start logic scan, and as master fails, its execution output scan will take place, and it will continue the process from the same point of execution. So your machine will never stop. Now, DCS has replaced this redundant PLC. DCS has replaced this redundant PLC. So DCS has come in market. DCS is exactly a redundant system. So if you go to industry, visit industry, power plant or any big plant, metal processing plant also they have. There you will find DCS, it will be of Almeida size. DCS will be of Almeida size. It will be kept like that. So in DCS you will have two CPUs, two input cards, two power supply, two communication cable. Everything you have double in that. So that is a redundant system. So you can see that PLC redundancy, SCADA system, HMI, everything they have combined and they have made one new controller, that is DCS, distributed control system. But you have the same process there also. Like you have many languages for PLC, all languages are there in DCS also. And in DCS you have software redundancy and hardware redundancy both. We cannot go in detail. So you can say DCS is a future, but DCS has capacity to control thousands, means you can say it can replace 20 PLCs also. So it has a lot capacity to control input output. So whole industry can be controlled from a DCS. But Individual machine you cannot control from DCS. So DCS will be used when it is a big industry, but in small industry where you have many machines for different work, but they don't have those many inputs outputs, that they will go with DCS. DCS we have to come to control whole industry like steel plant, cement plant. In power plant we have, you visit any power plant, you have DCS there. Nowadays in car manufacturing also it is coming, but PLCs will be there, and DCS is the advanced version. So this is the thing. Anything else?
Yeah, thank you for this.
Okay. Any other people? Okay, one question was there. Someone has had asked that how will it repeat the process, correct? So that also let me finish very fast. So keep patience, 10 minutes. And if you have another question, you can ask me, no issue. See this, how will it work? Look at the screen. First, you need to see the execution. So X2 is already on. Now, when I press start button, M0 will be on. M0 on. M0 is on. So Y0 on. M0 on. Timer is running. Its done bit has come. So done bit is on, you can say. Here it is done bit on. So as done bit is on, it is off because it has stopped it. It is broken. Now T0 is on. Y1 is on. T0 is on, this timer is running, its done bit has come. As its done bit comes, this is off. Now T1 is on, so Y4 is on, T1 is on, this timer is running, its done bit has come. So T2 has come. T2 will break this and it is off. Correct. Now T2 has come, Y10, T2 has come, Y3. Now as this will come, this you keep on, ignore this. As T3 comes, what happens you see? Concentrate. Till now, Y0 is off. And why is this Y0 off? You need to concentrate. Why is this Y0 off? This Y0 is off because T0 is breaking the path. This Y0 is off because T0 has broken the path. If you have to get this on again to repeat the process, you have to get Y0 on again. If you have to get this on again, you need to remove this break. You need to remove this break. And how can I remove this break? This is the done bit of first timer. So I need to switch off this done bit. I need to switch off this done bit. How can we switch off done bit? We can switch off by breaking its enable. So as T3 will come, it will break this path. As it breaks, this is off. Done bit is off. As done bit is off, this M0 is already there. It will on this. As this is on, see, up to this, I hope it is clear that as M3 T3 comes, T3 will break first timer. First timer will get reset. As it get reset, this done bit is gone. As this done bit is gone, M0 will switch on Y0, red. But with red, its timer for 5 seconds, with red, its timer for 5 seconds should also run. But this timer is broken by T3. But do you know, as Y0 will get on, at the same time T0 will also start. How you see? As T3 breaks first timer, two things happens. Two things happen. First thing is, this brake is gone, Y0 is on. At the same time, as this done bit is off, will not be off, will not this done bit off. So as this T0 is off, this T0 is off. As this T0 is off, this T1 is off. As this T1 is off, this T2 is off. As this T2 is off, this T3 is also off. It means this is gone. This brake is gone and it will also start. So when T3 comes, two things will take place at the same time. First one, this will remove the brake Y0 on. At the same time, below this timer, everything will be off. As M3 will break first timer, below this timer, everything will be off. It means T3 was on and off. T3 was on, it broke, and it was off also because here it was off. So when you break first timer, below first timer everything will be off, not below, not above that. So this is it. Is it clear? I am not sure that it will be clear, but a bit even. Tell me, is it clear? Or you can tell me if you have any other doubt in this, you can tell me. What I told, if M3 T3 is on, T3 will break this timer, and as it will break this timer, done bit will go, and below this timer everything will be off. So M3 will also get off. As M3 will be off, this M0 will start. See, M0 will start two things, Y0 and T0, and process will continue. Tell me. Is it okay? Who had
Yes, sir.
asked the question? Where, is it clear?
Yes, sir.
Okay. If it is not clear, don't worry. Tomorrow again you ask me, I shall do that.
Yes, sir.
Don't worry.
Little bit.
Okay. Little bit. It means it was not clear. But what I told, no, you check once. What I told, that when T3 will break first timer, below first timer, everything will be off. That you check in Codesis actually. It will help you. Okay. So
Okay, sir.
that is it. Okay. Today, so what we did today, finally, 2 minutes. Let me finish in 2 minutes. So we learned field devices, inputs, outputs, digital. Then we learned wiring concept. After that, we learned how do we communicate PLC, how do we download, how do we upload, how do we troubleshoot. That is it. So one project we did. Tomorrow, HMI and SCADA. So first half, we shall implement HMI on the same project. And afternoon, SCADA we shall implement on the same project. It would be real time. Okay, so tomorrow we will see that. I request you people to revise the things. At least during training, you revise the things so that tomorrow you
Sir,
can
I
understand.
have doubt on that.
Yeah, ask me please. Ask me. Tell me.
Hello, sir. I am audible.
Now you are audible.
Hello, sir. Am I audible?
Now you are audible. Tell me. But your mic
Hello.
is off. Now it is on. Yeah, tell me.
Yes, sir.
I think he has a network issue because it shows he left. He has network issue. Sahibas, you text me in WhatsApp. It would be better. Okay, I hope it is clear for all. We'll leave now. Coordinators, we shall leave. Thank
Thank you,
you.
sir.
Bye.
Thank you, sir.